my assistant, Mr. Bean. One medium-sized nail, 7 bars of soap, graphite pencils, 2,000 match heads, 1 medium-sized dose of salts, enough lime to whitewash a chicken coop, half a pound of sugar, enough sulfur to treat a dog for fleas, and water as required. May I draw your attention to this rather curious mixture of oddments? We have here all the required ingredients for one human being, medium-sized. It's a build-it-yourself kit of sorts, the material cost of which is only a few pounds. The operating expenses depend on what kinds of food you feed it. Food and water are necessary for all animal life. Food can vary from the very simple to the very fancy, such as this beautiful cake. All animals must eat. The food they eat is a compromise between what they need, what they like, and what they can get. Before it can be used by the body, most food must first be digested. That is, reduced to a form in which it can be absorbed. The simplest form of animal, the amoeba, digests its food by simply surrounding it. The human animal, on the other hand, although more complex, works on the same principle. The human digestive system is really only a 32-foot tube with an appetite at one end, the function of which is to start turning food into bones, toenails, ears, and hair, and to provide energy. All food, besides water, consists of a mixture of fats, proteins, carbohydrates, minerals, and vitamins. Man's digestion begins with his appetite for food. The first organ in the human digestive system is the mouth. The parts of the mouth that help to prepare the food for digestion are the teeth, the jaws, the tongue, and the salivary glands. The front teeth bite off small chunks of food, the jaws, moving in a grinding motion, and the tongue move the food around inside the mouth so that it comes in contact with the large grinding teeth at the back, which break it down still further. The salivary glands, which are stimulated by sight, smell, and taste, supply a fluid containing an enzyme called ptyalin, which breaks down starch and lubricates the food. The lubricated food then passes down the esophagus, or gullet, into the stomach, where the next stage in the digestive process takes place. Very little food is absorbed into the body from the stomach, whose primary function is to produce enzymes for further digestion. Glands in the stomach walls, stimulated by sight, smell, or by the presence of food, supply a fluid called gastric juice. This gastric juice contains an enzyme called pepsin, which assists in breaking down complex protein molecules, another enzyme called renin, which clots milk, and also hydrochloric acid, which neutralizes the alkaline food mass from the mouth and thus allows the enzymes in the gastric juice to start working. After 20 or 30 minutes, the acidic gastric juice has penetrated the churned up food mass. This is called chyme. This brings us to the small intestine. It is here, in a 20-foot length of tubing called the small intestine, that the main processes of digestion take place. The first 12 inches of this tube is called the duodenum, and this is the most vital part of the entire digestive tract. The acidity of the chyme entering the duodenum through the pyloric sphincter stimulates secretions from the walls of the small intestine and from two other glands, the liver and the pancreas. The liver is the largest gland in the body. One of its most important functions is to supply a digestive juice called bile. The bile is stored in a small sac called the gallbladder. It is distinctly alkaline and helps to neutralize the chyme and assists in the absorption of fats and fat-soluble vitamins. The pancreas secretes an alkaline fluid called pancreatic juice. This juice contains other enzymes, including trypsin and amylase, which help to break down the particles of protein and starch, and lipase, a fat-splitting enzyme. As chyme enters the duodenum from the stomach, the pancreatic juices from the pancreas and the bile from the gallbladder flow into the chyme. The pancreatic juice helps to break down the proteins, carbohydrates, and fats, while the bile neutralizes the acidic mass from the stomach and assists in the absorption of fats and some vitamins. The final stages of digestion and absorption of the nutrients also take place in the small intestine. The small intestine has three main functions. The first, to supply more enzymes for further digestion. The second, to churn the food mass and move it down the length of the intestine by rhythmic contractions called peristaltic movements. And the third, the absorption of nutrients from the digested food mass. During absorption, the nutrients pass through the walls of the small intestine into blood and lymphatic vessels. Most of the fatty nutrients pass into the lymphatics, which join up with the blood system above the heart, while the non-fatty nutrients pass into the portal blood vessels to the liver and thence to the rest of the body. To sum up, the mouth plays the first important part. The salivary enzyme, ptyalin, starts preparing the food for digestion in the stomach, where the food is mixed with acidic gastric juice forming chyme, which passes from the stomach into the duodenum, where the bile from the liver and the juice from the pancreas further help digestion, and then to the final stage of digestion in the small intestine, from which the nutrients pass into the blood and lymphatic vessels. By the time the food mass has traveled the length of the small intestine, all usable content of the food has been absorbed and distributed throughout the body. As digestion is now complete, It only remains for the large intestine, or colon, to reabsorb most of the water and minerals and to collect the unabsorbed materials, such as cellulose, until they pass out of the body. The amount of indigestible material, or roughage, largely determines how active the colon will become. The average time for materials to travel the length of the 32-foot digestive tract is about 36 hours. All food that one eats goes through this process of digestion. Whether it be fish or like this beautiful cake. Oh, my.